Hi, everyone, and welcome to my talk, Azure's Weakest Link. This is me. I'm Håkon. I'm a security consultant and researcher working at Binary Security, a consulting firm based in Norway, where we do almost exclusively white box application pen testing. So what that means is basically that we test customers' applications with full access to their source code, with full user privileges and administrator privileges, and access to their infrastructure and configurations to get the most in-depth pen testing that we can do. And what happens is that if it's a well-secured application we're testing, we have some time to look at the actual infrastructure that supports it. And also we spend our 20% research time on finding bugs in these kinds of infrastructures. And in Norway, that is mostly Azure. So this is the story of one time I found a bug there, or several bugs there. So the initial vulnerability discovery came from when I was looking at an Azure Logic app, because we were doing a customer engagement, and it's a bit sad, but it was quite well secured, so we had to go looking elsewhere, and we had access to their Azure portal. And they had some logic apps, and what we usually do when we kind of look for bugs in logic apps is that we try to find unmasked secrets, because that's kind of it in that. A logic app is basically a web app that responds to some kind of input. So in this case, when an HTTP request is received, it's going to perform some actions. And what developers usually do is that they forget to mask their secrets, and then you can just read them out here as a low-privileged user and escalate your privileges, right? But no such luck in this case, which got me wondering what else can I do here. And I kind of considered these weird symbols. What do they mean? And as it turns out, what this means is that there is an API connection there. And an API connection is something that you might not have heard about, even if you do work in Azure. But you can be surprised by how many API connections you actually have in your tenant, because these are automatically created whenever you create an action that requires them. And they're not necessarily deleted if you delete the action or the logic app. So after a while, they kind of pile up. And you've taken no steps to explicitly create them. And if you click on one of them, you kind of see this, which is not very interesting. This is a Slack connector, so we kind of assume that it does something to Slack. But what is interesting is the actual response we get when we click on this, as an HTTP request. We get a response that includes this. And this is very interesting for us. And first of all, we're going to check out the first red square there called test links, which is basically a URI that looks like this. And bearing in mind that we are a low-privileged user in this tenant. So this is a request to Azure Resource Management. And that is the thing that manages resources in Azure. So this is the service that you kind of call whenever you want to do anything to anything in Azure. So if you want to create a web app, or if you want to get some information about your API management, or if you want to change something, this is the service you're talking to. And the URIs are always built in the same way. You have the subscription you're talking about, you have your resource group, then you have the type of API you're talking to. So in this case, it's a Microsoft Web /connection type. Then the resource itself, the name of it, and then the actual action that you want to perform. And there are several interesting things about this action. It's called extension/proxy, which we kind of think, oh, that's pretty cool. We're proxying to Slack in some way. And it ends with conversation.list. And if you have worked on Slack at all, you would know that that is, in fact, an endpoint in the Slack API to list channels. And the most interesting thing about this is that it's undocumented. And in my experience, whenever there's an undocumented API in Azure, it is filled with bugs. But if you call this, like as a reader, you get back a list of channels. And that is exactly what you would expect if you were calling the API directly, which kind of makes sense. But who is doing this call, right? Because is it me? I have a Slack user in this tenant, and it's like SSO and blah, blah, blah. So is it just me doing this kind of thing? Well, it turns out it's not, which we see if we try another endpoint called do not disturb, set snooze, basically setting the do not disturb status for 5 minutes, and it responds with snooze enabled. But I check the Slack, like the customer Slack where I'm in, I'm not snoozed. So who is? That's kind of the question here. And I tried to figure it out by like doing conversation.join to like join a channel and see who joined it. But we got access denied. That is actually not a surprise. And we will see why that's not a surprise later. But as like a temporary conclusion, we can say that any GET request action on an API connection can be called by readers. And then there's the obvious question, where readers being low privileged users. But the big question is, what are the actions we can do, and who is doing that action? So we go to Microsoft documentation, and they have this extremely nice diagram, which is accurate and informative, which is not very common. And there's only like one big omission in it that we're going to use to exploit it. So zooming on like the left part here, we see we have some resource types that communicate with an Azure API management. Now, we don't care about Power Automates and Power Apps. We're only concerned with logic apps in this case. And what this logic app is going to do is going to have some input, a token, a connector ID, an operation ID, and a connection ID to communicate with this Azure API management, which it says has a Swagger. And actually, if you know where to look, you can find the Swagger, and it's quite clearly defined, and you get all the actions you can take. So you're restricted by the Swagger. You don't have full access to the entire API, because that would be crazy. And then what Azure API Management is going to do, it's going to take the user token that was input and the connection ID, and it's going to query this magical credential and metadata store and retrieve the connection token. And that kind of answers our question, because it is the connection token that is the privilege that is calling the endpoint. And that is the token that was used when setting up the API connection in the first place. So that can be like OAuth parameters, it can be an API key, it can be whatever kind of secret you want, but that's what's going to be used in like the later portion here. Ignore this part. And assume that it's just going to use that token to do a direct call to the backend service. So in our example, Slack. But this is all a bit academic, because if we try to call this, and I say if we try to call this global APIM host, which is not global, but it's basically global because it's segmented by location, and you can create an API connection in any location you want. So you have this URL, and then you have the connector type, and then you have a connection ID, which is a kind of obscure hash here, and then the actual action you want to do. But this doesn't matter because we are denied. And specifically, we are denied because we are not in the connection ACL, so the access control list for like our reader user. And it's the token store that denies us. And until very recently, you could just kind of visit the token store and see this nice page, but they have blocked it now, so you will no longer be able to see this. Well, it doesn't really matter. But by default, you have that only the logic app itself, like the logic app you used when creating the API connection, is able to call the APIM instance. And you can go in here and you can add your own kind of service principles and whatnot, but no one's going to do that, so it doesn't matter. But remember, we could call it, and we did call the API connection, and we got a response from Slack. So how did this happen? It is because there is another entry into the connection ACL, and as a graphical view of that, it looks like this. And the Azure Resource Manager has access to it. And that explains how when we used like our request through Azure Resource Management, we could call Slack. And to understand why they did this, like why they made this so, you have to know some things about Azure. And these are things that may not, strictly speaking, be facts, but they are quite accurate and they work, so there. And the first thing is that there's a simple security model. And it's kind of been altered over time because people find bugs in it, but in like essence, if you're talking to the APIs in Azure Resource Management, you have the security models that the readers can do all GET requests. So I kind of prove this or show it by saying that as a reader in this subscription, I want to call this API that doesn't exist. It's going to tell me, I don't know what you're talking about. But if I change this to a post request, it's going to immediately say authorization failed. Because it already knows that I don't have permissions to do a post request on that subscription because I'm just a reader. It doesn't need to consider the rest of it. And then like another proof is that it's very common in the documentation to have like sensitive endpoints being empty post requests. So if you want to list host keys on a web apps, for instance, then you need to do a post request, but it has to be empty. And here's another example, right? So that's like the first thing. And then the second thing is that ARM, the Azure Resource Manager, does all the authentication and all the authorization on every endpoint. And then it's going to query the backend using its own token, which owns that resource. And I don't have any explicit proof, but I just wanted to show how it works. So if you're communicating with the Azure Resource Manager using the portal or like directly with HTTP or through the CLI, it's going to do like a role check here in the authentication part. And it's going to check like, for instance, if it's a GET request, are you at least a reader here? And if it's a POST request, are you at least a contributor here? And if that kind of checks out, it's going to query the backend, so be that a web app or a VM or something, with full control, with a token that has administrator permissions on that thing. And like the only way to show if this is true is to see where it goes wrong. And here's an example of where it goes wrong. So you have a get functions admin token, which looks like this. It ends with functions admin token. And it's an API that's directly copied from Kudu, the thing that runs web apps, where of course the authentication and authorization rules are that you have to be an administrator to get the functions admin token. But since the ARM developers just straight up copied that endpoint into their API and forgot to check anything else, you could call this as a reader and get the functions admin token, giving you RCE on the web app. And I found this a couple of years ago, and I reported it, and then Microsoft fixed it, and then they said, we have already known about this for several months. And a similar example here from a more recent blog post by Token Security. It's basically the same thing. There's an API and it's a GET and it's sensitive. So you could get the VPN shared access key. Right. But what does this mean for API connections then? Well, we know that we are querying the backend service using the token that was set up when creating the API connection. And we know that we can do all GET requests. So what we need to do is see, are there backend services? Does there exist a backend service in the world where a GET request can be sensitive? It's basically the question. And of course, the answer is yes. And I have some examples here. This is an Azure SQL database. And to no surprise, if you query this, you have the ability to read all values in the SQL database as a low-privileged user. And then I have like a fun example here. If you try to, it had to be redacted a bit because of customer data, but if you kind of do this weird try for a path traversal, you're going to get a response with HTTP 502 and then a stack trace in the status message, which is not like a common way of having errors. showing up. But then another example here, Jira. In the Jira case, right, your Jira instance can be anywhere on the web, so it needs some way of knowing like where it is. So instead of like setting that up when you're setting up the connection, which would be like a normal, insane way of doing it, you have to add this header to every request. So like, and if you do it, it's going to send that request to that service, and you receive the API key. So now you're not restricted to anything anymore, and you have the API key to the Jira, and that's probably going to be like an administrator user, right? Because you set this up for a reason, right? And then the big one here is the key vaults. And of course, you can read all the secrets in the key vault. So that's like pretty free. And for those that don't know, like Azure Key Vaults is the thing that safeguards encryption keys and all your secrets and your SSH keys, like whatever. That's where you store your most sensitive things. So that's pretty bad. And then I reported this. Like I reported the general case and the Jira case separately, because the Jira case is kind of like just another bug. And after a week, they fixed the general case and immediately replied on the Jira case saying, oh, we can't reproduce this anymore. And they just closed that. So that still works, but you have to be, owner on it. And then they spent a couple of more weeks and concluded that they had known about this bug for several months. And what exactly did they fix here, right? Well, now if you try to call this extension /proxy and then an endpoint, it's going to tell you that that's not allowed. You can only do the explicitly defined test connection in URI, right? So for Slack, that's conversation.list. So basically, they whitelist those paths. But then that kind of begs the question, like, there are many API connections. Like, these are a subset of the ones starting with A. And do they know that all readers can call the test connections? Like, who are defining these test connections? And I'm not saying like that there are lots of them that have sensitive data that kind of comes out, but I think it's more than the developers maybe intended. But could we do more? Like, we didn't get a bounty, so can we do more here? Remembering that all connections are hosted in the same place, this global APIM instance. And if you go back and remember slide 9, which was a real highlight so far, it looked like this. And we were only considering the top square there, but if we zoom into the middle one, you see another kind of endpoint, which is really interesting, this dynamic invoke endpoint, which is also undocumented. So that's kind of our next target. Sadly, it's a post request, so we know already that we have to be like an owner or a contributor to call it, which kind of leaves us with no way of doing a local privilege escalation in a tenant. Because if you own it, then let's just assume that you are highly privileged in the tenant. And then there's a body here, and you can see that it's like, it says it's a method get and then a path that is conversation.list. So we kind of assume that this is going to return the same thing as the test link, because it's the same endpoint. And to the surprise of no one, if you try this, you basically just copy the whole thing and send off the request. And being owner or contributor of the API connection, of course, you have the same response. So, OK, that makes sense. But then we have to ask ourselves, are we still restricted to just the test connection instance? Because if we are, then this doesn't matter. And what is great is that we are not. So we can call any endpoint again. Any action is defined, but we are now owners, so it's not like high severity bugs we can find like in the local case, because we already own the resource. Although this is probably a bug, since like you can read all the secrets in a key vault, just being contributor, which if you have like RBAC set up, shouldn't be allowed. You need like a specific role to do that. But interestingly, in this thing, we have path parameters. And path parameters that are not in the URI itself in Azure is quite rare. And the reason it's quite rare is because it's so catastrophic if it's exploited. So let's see. And to illustrate what happens here, I made this diagram, and here I am, and I want to call an endpoint on like an API connection with some method and some data. And the Azure Resource Manager is going to do a role check, and it's going to conclude that, of course, you're allowed to do this because you own the API connection. And then it's going to do some kind of validation on that path and method, right? It needs to be in the Swagger for you to be able to call it. And if that gets validated, it's going to do a path join on like the host, which is the APIM instance, and then the connection ID, which is baked into the API connection, and then your path that you want to call, which is, of course, it already knows is valid. And then it's going to use that to call the Azure API Management instance. And that's probably a bad idea, because what we can do is probably do some kind of path traversal here. And to make this to make the easiest kind of example here, I created my own custom connector, basically saying that I don't want to go searching through the Swagger for one endpoint that I can exploit. I just make my own, and it's going to be hosted in the same place. And what happens if you make it? Like, you get this nice Swagger view. And what you're going to do is define a path like this. Like so, /path and then a string parameter. And the hope being that if you do a path like this, where this is like in the Swagger already, like this weird path, you kind of try to path traverse back down to the root of the APIM instance, and then up again to another victim API connection, which you shouldn't have access to. And the hope is that when ARM sees this request, they will accept it, and then kind of make this type of call to the APIM instance, where it's like first my connection, like my custom connector, my connection ID, and then all the way down to the root again, and then the victim's API connection and their secret in this case, right? Because this is a key vault connector. So let's see what happens if we try to do that. So here I am in the victim's tenant, and the victim has a key vault, and there's a secret there, and of course it should be impossible for anyone to read it if they don't have very specific access to it. And he has made an API connection to it. And here you can see that that's like the connection ID, which is this hash value, which could be difficult to find, but it's possible. And here I am in my attacker tenant. I have my custom connector, and it's going to be the same as we just showed. It's going to be like path and string parameter. And here I'm trying to search for the UPN to show that it's actually the attacker doing this. There it is. And I'm calling my custom connection, and we're path traversing down to the root and up to the victims. And you see that it's the same connection ID there. And we can list the secret. And after listing it, because we didn't necessarily know what it was called, we can actually get the value of it. Right, so there we have it. So that's a totally unauthenticated cross-tenant key vault secret leaking, basically. Yeah. Nice. And Microsoft response. So I submitted it, and they fixed it in about 2 days, which is great. They spent a couple of weeks, and then they concluded that I get $40,000. Hey. which is fine. Which is fine. And what did they fix? Well, if you try this now with like this path here, %2e being dot, for those that don't know, so this path dot/, it's going to tell you that path is invalid. So basically, they blacklist that. So if you have another path traversal, or if you have a way of changing the connection runtime URL, this is still valid, and you can get $40,000 for it. And then I have some takeaways if you want them. And the first thing I want to kind of stress is that hacking Azure or anything is not black magic. Yeah, I know it's a black box technically, but if you kind of spend some time thinking about the security model and how they usually like make this architecture, it's quite easy when you come across an endpoint like dynamic invoke or extensions proxy to make exploitation easy, right? You absolutely can know just by looking at an endpoint that this is a bug, right? So understanding is like key here. And then the second thing is that the fix is silent, right? There is no announcement, there is no CVE, and there's nothing coming out from Microsoft about this bug. It's not a particularly difficult bug to find really, and now that it's fixed, that's fine, I guess, but you have no way of knowing if you were exploited by this, or if you're like if you ever were vulnerable to this. There's no announcement and there's no like coordinated effort to say maybe you should change this, right? Because people could have accessed your Salesforce instance or your Jira or taken all your key vaults if you had this. And then I think I have about 3 minutes for questions if anybody has any. So you can step up to the microphones, I think.
Hi.
Hi.
I just have a quick question. First of all, thank you so much for presenting this talk. How does the logs look like in the victim's account when you're trying to read the secret values? So since you have mentioned that you'll never come to know, but does this information available in the logs or everything is happening from the Azure side so that information is not visible to you at all?
So I'm not really a log guy, but what would happen in the logs is that it would say that an API connection, the API connection you set up, accessed your key vaults, for instance, which is an expected thing because your logic app is doing it also, right? Whenever your logic app runs, it's going to access that key vault, potentially.
But in case of cross-tenant, because you're trying to access the...
Yeah, but you're doing it with the authentication of that logic app, so that's what you're going to see. It would look like your logic app is accessing it.
Okay, thank you.